The city is probably the oldest, most enduring invention of our civilization. The words are interchangeable: civilization, civil, civic, city. Cities evolve over time. They respond to crises, and historically, they emerge from crises stronger than ever before. So what are the future trends for cities, and what are the lessons of history?
Hello, I'm Tim Stonor. I'm an architect and an urban planner. And today I'm going to be talking about digital urban planning and design. We're going to look at some reasonably new computational approaches to the generation of designs, with a particular focus on the way that cities work. What happens in the streets of cities? How can we generate the thriving life that makes the difference between a great city that has a buzz and a poor city which doesn't deliver on its social or economic potentials? To begin, I want to dedicate this talk to Professor Bill Hillier, who sadly died 2 years ago. Bill worked very closely with Norman Foster in the 1980s to pioneer a new form of master planning that was built around computational analysis, but very much focused on the design of great streets and spaces, notably amongst which Trafalgar Square was a remarkable project that set a new standard for public space design in the United Kingdom, with ripples that have been felt throughout the world. The steps of Trafalgar Square are now a place to be in, to be seen in. And those resulted from a process of analysis and computational design that I'm going to take you through in this talk. But let's start by considering some of the key drivers of change that influence all practice: architecture, urban planning, engineering, systems delivery, service delivery. And those drivers of change are, on the one hand, environmental. They relate to climate change. They're technological. For example, increased large-scale automation. We, on the other hand, have societal and economic drivers: austerity, inequality, an aging population. And following on from those demographic drive of age, we have a growing population globally. This creates a series of impacts on the way we work, our employment, skills, impacts on air quality, impacts on the way that we can deliver services, and impacts on the way that people are housed and whether we can supply enough decent and affordable housing for people. This creates also a series of opportunities that we as practitioners can respond to. These are urgent drivers of change that generate opportunities for new models of welfare, new ways of distributing economic benefits, universal income being an idea gaining popularity, but also new models of mobility. The way we communicate online and on land is changing rapidly, provoked, of course, by the coronavirus. And then enabling all of this are technologies, new computational platforms, new systems of economic exchange with tokens, with blockchain, new forms of design involving digital twins or even digital siblings, simulating before we deliver in new ways. And of course, the foundation, the Norman Foster Foundation, has been the heart of much of the debate, much of the conversation, much of the thinking about the new knowledge that will be required to act on these drivers, to address these opportunities, and to respond with the enabling technologies. But let's just consider where we've come from in order to consider where we might go next. Where we come from is a situation globally where most cities are characterized now by traffic congestion and the air pollution and the health problems that relate to traffic jams. It's almost the only common thing globally about cities. And of course, it's a highly negative common badge. This is where I want to focus today. How can we decongest the city by moving differently and communicating differently? And we need to do this because the pressures on cities are only going to become greater. The future is one in which people are moving to cities. The world population is increasing. The urban population is increasing. Unless we do things differently, the informal urban population will increase. More people will live in slums. And at the same time, more people will get wealthy, growing the unacceptable inequalities that already exist. So the future is cities, but what kind of city? And we can't continue in the fashion that we have been developing over the last century. Let me show this one slide, which I think puts its finger on the difference between where we are now and where we once were. It's our greatest urban challenge that fast highways have replaced main streets in many of our cities and are continuing to do so as cities are growing around the world. Those fast highways that separate the movement of cars from the movement of pedestrians. Contrast the situation on the left, which is a city in the Middle East, with the city on the right, which is Paris, the Champs-Élysées, which is a main street mixing how you walk and where you drive and where you cycle. The buildings front the Champs-Élysées. The property values are the highest on the Champs-Élysées. In the city on the left, the buildings turn their back on the highway and the property values are among the lowest in the city. Now, where did this come from? Well, we can certainly trace the origins of this approach to city design, this negative approach, to the Plan Voisin by Le Corbusier. A noble intention to make the city more efficient, but one which separated high-speed cars from slow-speed pedestrians. Of course, that plan sponsored by the Voisin automobile company and Le Corbusier's own example belonging in the collection at the foundation. A noble idea to use the car to create new forms of mobility, but one that was highly damaging to existing places and has been highly damaging to the creation of new places. Take, for example, the traditional city. And we can see in that, if we look here at a fine tissue of highly connected, highly permeable streets and public spaces, dominated by a few long streets and many short streets, in which the foreground of the streets is a place of positive public activity. Now contrast that with the way cities and towns were designed in the 20th century, where the foreground was dominated by two things: a green landscape, which on the one hand would seem to be positive, but a green landscape hiding the second element, the fast highway, which has been highly divisive. This example here is a new town in the UK, where we know there is no adequate public transport system. People find it difficult to walk across this landscape. They feel unsafe. And there are high levels of mental health among the population living there. The good intentions of architects have not always been realized in the best places for people. So what we can see is the challenge, the number one challenge: the fragmented city of disconnected developments on the left, or the integrated city of continuously connected neighborhoods on the right. Your choice. Which one would you rather build? Which one would you rather live in? Is it the city of car dependence, obesity, and loneliness, or the city of walking, cycling, and livability? Clearly, it's got to be the latter. It's got to be cities like Barcelona, cities like Madrid, cities like Paris, all of which have been built around great places for people to be. And this isn't just about simple enjoyment. look closer at how people behave in streets and public spaces, and there is a myriad of activities being undertaken, from simply being present, co-present with other people. And then the beginnings of communication, a wave across the street might lead to an interaction between people that might itself develop into a transaction, perhaps an economic transaction or a social transaction, the creation of a friendship, the creation of a business partnership. Being introduced to people in public space, at a bar, at a cafe, is a very everyday thing, but put it together globally and you have a process of innovation, a process where those introductions lead to new ideas being created that had never existed before. Ideas that can then be broadcast among the community. So look at a simple public space, you're actually seeing what I call the transaction machine. Cities are transaction machines. We have cities for a reason. They are to help us understand our problems and then find the solutions to those problems. Cities are giant computers, only if we build them right. And if we want to build them right, we have to build great streets and great public spaces to create those places where people can generate those relationships and create those transactions. Now, at Space Syntax, we've created a science around the connectivity of cities, the way in which people move and the way in which their movement and interaction is influenced by the degree to which streets and public spaces spatially connect. The key property in the Space Syntax approach is spatial accessibility, the degree to which any street or part of a street is connected into the wider network. We use a highly simple graphic system where the best connected streets are highlighted in red, then orange, yellow, green, through to the least well-connected streets in blue. This property of connectivity is measured by an algorithm that journeys from every street origin to every other street destination and calculates the simplest route from origin to destination, finding not only the shortest route, but the route that involves the least wiggle, the least deviation from a straight line. And we've discovered through research that those two properties of distance and simplicity explain how most people, most of the time, make decisions about how they journey through cities. Run the algorithm, you can create a value for each street, represent that as a color. And you have a very simple, straightforward, relatively quick and affordable reading of the mobility hierarchy of a city. And you can see instantly how the city then works. Because the research shows us our key discovery number one, that spatial accessibility predicts movement of both pedestrians and of vehicles, cycles as well. The more connected streets are the streets that naturally gather more movement to them. We call it natural movement. And that means that these analyses can become design tools. We can use them in the master planning and design process to test design concepts. Indeed, Bill Hillier, Norman Foster, and colleagues worked on a highly influential master plan in the late 1980s at King's Cross in London, using this design tool to test ideas for new connections. It's a data-driven urban planning and design process. You take your scheme, add it into the analysis of the street hierarchy, and run the analysis. In this case, this experiment of a highly connected local grid is not itself then highly connected into the wider city because its streets don't connect seamlessly into the wider area. And that, if you like, is a golden rule in urban master planning. If you want to generate movement on any particular street, you have to connect it into the wider network in a simple, straightforward, and linear way. Being connected locally is not good enough. So go back to the drawing board, test a design that does that takes local connections and stretches them out into the wider area. And by running the analysis, running the design tool, you can see here that we have created a more connected, hotter, overall foreground network of streets. into which we can then place secondary and tertiary streets. This is the beginnings of the thriving life that creates the transaction machine. The second key discovery that the research program at University College London and now throughout the world has made is that spatial accessibility influences land use viability. So those highly connected streets become the naturally best location for retail, for land uses that need movement to make them work, need footfall. This image of London shows all the shops in red. 80% of London's retail is located on the 20% most spatially accessible streets. This isn't by chance, and it isn't just London. We find this in towns and cities worldwide. We also find it in unplanned settlements. Left to our own devices, the human species creates connected grids into which land users can then drop the retail on the main streets, the residences in the back streets. It is, if you like, the influence of architects applying unproven theories, which seems to have messed this up in the 20th century and created so many of the problems that we've now inherited. Now, by putting these findings together, the spatial accessibility influencing movement and spatial accessibility influencing land use, we have a form of integrated urban modeling that I'm now going to show you some examples of use in practice on master planning projects worldwide. Integrated urban models are becoming, and my prediction is will become, the main tool of urban master planning in the decades to come, because they give us this data-driven understanding of whether our planning proposals are likely to work. They also address everyday questions. They address user-focused outcomes. How many jobs could I reach in, say, half an hour of where I am? Can I walk to a health center, a doctor? And are they a decent doctor based on data sets that might describe their performance? Am I close to shops? And in thinking, as the master planning process requires us to think, in thinking about how everything works together, what's best for everyone? Let's just add a few more other discoveries first before we move into the case studies. A third key discovery is spatial accessibility influences crime and safety. No one understands space better than criminals who exploit it. Burglars, housebreakers in particular, exploiting the disconnected, quiet streets where we find from police records, police data, more incidences of crime. A fourth key discovery, spatial accessibility influences land value. We're seeing more and more very good data from cities worldwide that spatial accessibility fundamentally influences the value of land, to the degree that we can then build forecast models that don't just talk about the movement that's likely to take place in streets, but the long-term urban value that's likely to be generated by having the benefit of that connectivity and that activity. So, for example, in our master plan for the city of Darwin in Australia, which we developed with Design Urban, we created a vision for the city built around streets and public spaces that was then supported by rigorous analysis of the underlying urban values being created, so much so that we could demonstrate that the master plan would generate 3.7 billion Australian dollars of land value, not just on the site itself, but in the surrounding area that would also benefit from the increased connectivity. Development has a ripple effect, either a bad ripple effect or a good ripple effect. Spatial modeling allows us to predict which one it's going to be. And as we learn more about these tools, so we're adding more variables into our multivariable regression models. For example, access to public transport, the degree to which land uses are mixed. Key discovery 5, spatial accessibility influences your mobility choice. If you can walk, you will walk more of the time. So we can see more people travel to work by car or van on the right in those less accessible parts of the city. People walk more in red where the streets are more highly connected. This is something that then has a health influence. Spatial accessibility influences physical health outcomes. More spatially accessible places generating more walking have higher health outcomes. And what's interesting with health is that these are not just physical health outcomes, but mental health outcomes. The negative consequences of disconnected, low density, isolated planning is loneliness. People not having local neighbors or enough of them to generate social networks and feeling lonely as a result. So at Space Syntax, in summary, what we're doing is bringing together data sets, geospatial data sets, and then investigating the relationships between how the city is connected together as a network of space, how that influences mobility, and how that then has social and economic, societal and health outcomes. And of course, it's not just the connectivity of space that matters. It's other influences, such as here working with Foster and partners in Masdar, looking at the influence of the sun. You might have a beautifully connected street, but if it's in full sun in the early afternoon, people are going to avoid it. So you have to mix the data sets together. And our interest, as well as working on master planning projects, is to develop the technologies behind them to create digital urban platforms that can then be used for a series of operational outcomes, be that transport planning or health and well-being planning. And these platforms then become the mediation between those drivers, those impacts, the opportunities and technologies that we saw at the beginning, and the ultimate applications that are going to be needed in order to make the change happen that's required. Those applications involving the necessary process of decision-taking, community engagement, having people on your side because you can explain to them why you're doing what you're doing, having an intelligent conversation that generates trust. These are also big issues for our profession. We've created, as a profession, a lot of failure, we have to admit. Being able to then address that and demonstrate the transparency of processes that are proven to work is for us a key driver to the fundamental mission that we have to develop these technologies, apply them, and then disseminate them, which we've been doing on many projects now over the years. The most important aspect for me about this process is that we test it in practice continuously. So through consultancy, through master planning, through building projects now over 30, we know that these techniques work. One of the big risks for smart cities is it's full of technology providers who say they have the latest big idea. Well, we've been able to build and go back and test and improve and evolve these processes across cities and regions at the finer scale of individual property developments, and then inside buildings themselves to show through actual built change that these techniques work. And if they don't work, we improve them to make them work better. Whether that's in the Tate Gallery, the British Museum, or a rapidly growing city in China, which is one of the big challenges for development today, that development is happening so quickly. How can we use computation to get ahead of the very rapid processes of change and lock in a sustainable plan early in the process to then guide that change? Another key application is in unplanned settlements, where we see so much of the global population living in slums, unplanned and informal settlements. We've been able to, here in Jeddah in Saudi Arabia, identify the high levels of walkability of those informal settlements. And although the building quality is poor, to say as part of our master planning activity, let's not lose the walkability as we increase and improve the quality of construction. So the model's been used to take the connected, walkable heart of the unplanned settlements and then grow them out into the wider network of vehicle-dominated streets where the wealthier population are moving, and try and bring those two communities of mobility together to connect the central streets of the unplanned settlement to then slow down the external streets of the otherwise fast-moving highways, to turn the highways into boulevards and let the two communities trade off each other. That's the essence, in this case, of these master plans. Retail is such an important and fundamental aspect of human existence, the way we buy and sell, that we've seen many applications of the technologies now on high profile, large scale retail developments. And in that, we've been able to influence, I think, the fundamental concept around shopping malls, turning them outside, connecting them to the city, connecting retail back to where it belongs, which is an urban experience, and working against the prevailing thinking, which was to over-internalize, lock in people and try to make it difficult for them to find their way out of these retail centers. We're urbanizing the process of retail in centers that we've been able, through surveys, through modeling, and then through forecasting, to predict the ultimate movement flows through. I'm going to finish with one final case study, a recent case study from the country of Kazakhstan, where Space Syntax won the international competition to master plan the future of the city. And in doing so, we addressed the headline objective of the city, which was to grow, but also to improve and intensify its existing neighborhoods, to move away from the car towards public transport, but also to improve the walkability and cyclability of a city which has environmental challenges, very hot in the winter, very cold in the summer, a very strong wind that blows through all year round. And our response, as you can see, is built around boulevards and streets and public spaces, which can modify the climate and also create those conditions that encourage walking and cycling, create the density that makes public transport economically viable. As I run through this sequence of slides, I'm showing you our competition entry to begin with. In terms of expanding the city, growing it, we identified the best direction of growth was towards the south and east. We start with the noise pollution, identifying noise from the motorway, identifying noise from the takeoff and landing cone of the airport, and saying, let's try to avoid those in terms of where we place new development. Identifying flood risk, and again, those parts of the land that are more likely to flood become places where we try to move development away from. Then the areas of sensitive landscape, where we have high quality soil and places, trees that have been planted that we don't want to have to cut down in order to build new buildings. We want to grow around and incorporate into our new city. Put those together and we have site sensitivity parameters, which create more developable land in red, less developable land in yellow. We then trained an algorithm to run from a set of gateways between the existing city and the new development area. And that found the natural lines of movement back to where I mentioned earlier, the shortest and least complicated lines of movement between the gateways, to establish the foreground street network of the city, main streets, the main boulevards around which the neighborhoods would be created. Zooming in, we ran optimizing algorithms to identify the secondary and then the tertiary networks of streets. And at each stage, you can change the density settings, the floor area ratio, the plot width, the plot depth settings in order to train the algorithm to create different levels of option. In the end, we've developed a typology of building forms, more commercial, taller, more denser, deeper blocks in red, then high density residential in orange, and lower density villa residential in yellow. This has all emerged by growing a city. And We're very excited about this process. We're very excited about using algorithms to make designs, not because it removes responsibility as architects from the ultimate design, but rather because if we're going to make the change that's required globally, we need to be able to create plans in places where there are no architects. And going back to where I started with the drivers, those opportunities, if we look geographically at the planet, the places in which urbanization is happening at the fastest pace are those places where the professions of architecture, planning, engineering are least established. And for me, a computational approach, a digital urban planning and design approach, is not just a luxury, but it should be a necessity. And that's what's driving our mission at Space Syntax. How can we improve these tools to make them as automated as possible? How can you take a satellite photograph and build a city from the kinds of soil, topology, water data that can come back from the satellite analysis, and avoid having to go through the expensive, complicated processes that are typically the case when you're making a planning proposal in a developed economy? So to end, I'll leave you with 2 or 3 things. First of all, a film to show how in the existing part of Nur Sultan, Kazakhstan, the existing neighborhood here called Technopark can be automated in terms of the processes I've described: spatial connectivity, leading to land use allocation, leading to building massing, growth, all automated in a design process, and creating the kinds of streets and public spaces that are more like those that we saw in Florence and less like those that we saw in the new UK New Town, places that are much more likely to support thriving life. In terms of resources, if you want to read further into the ideas that I've just shared with you, I would direct you first to the Space Syntax online training platform, spacesyntax.online. There you can find an explanation of the methodologies I've described, the underpinning theories behind those methodologies, and some practical cases. If you want to read more deeply, please take a look at Space is the Machine, Bill Hillier's seminal book about space and society, and take a look at the training options for self-training and taught training that are also available. I've enjoyed sharing these thoughts with you, and I hope that they resonate with your own interests and practice. Thank you very much.